Hey there, HackerFrogs! This is the second Intro to Web Exploitation workshop. In the previous workshop, we learned about the following web exploitation concepts. Directory indexing is a vulnerability on websites that allows users to see the file contents of web directories, which can lead to sensitive data exposed to arbitrary website visitors. Robots.txt is a special file included on certain websites that indicates which files on the website can/cannot be indexed by search engines. It can be abused to point malicious users to sensitive parts of the website. The HTTP referrer header contains the value of a complete or partial address of the web page that is making the request. It's often used for analytics or logging. The HTTP referrer header is occasionally used by web app developers as a security mechanism, but this is not a good practice, as it was never intended to be used in such a way. HTTP cookies are commonly used as a security mechanism that allows users to maintain an authenticated user session on a website. In short, HTTP cookies allow users to log in to websites. But since cookie values can be modified by the user, proper care should be taken to ensure that valid cookie values are not predictable or easily guessed. Let's pick up where we left off in the Natas CTF. If we recall from the previous workshop, for each level of the Natas CTF, we need to log into the level's webpage by providing the name of the level as a username, as well as the password for the level, which is obtained from the previous level. In our previous workshop, we were recording the passwords for completed levels in a text document. But keep in mind that the passwords for the Natas CTF levels change every few months or so. So the passwords shown in this video are not likely to be valid anymore. That said, we find ourselves on the landing page for Natas 6, so let's go over the concept we'll be using to solve this level. Sourcecode analysis is the process of analyzing the code of a piece of software with the goal of deeper understanding regarding its function. In the context of web exploitation, the code involved is usually written in HTML, CSS, JavaScript, PHP, or Java. Therefore, successful source code analysis requires a certain level of familiarity in the language the code is written in. Back on the Natas 6 landing page, we have a field for submitting a secret of some kind. If we provide the wrong input, the app tells us so in its output. However, there's a link on the page that leads us to the web app's source code, so we open the link as a new tab and access it. From the opening and closing angle brackets with question marks, shown here and here, we can deduce that this is PHP code, which is a popular web development language. The top of the PHP code uses the include instruction, which imports PHP code from another file, which in this case is the secret.inc file in the includes folder. Further down, we see that if the value of the secret variable is the same as the value that is posted, then the password for Natas 7 is printed. But the code doesn't specify what the value of the secret variable is. So the secret variable must be contained within the secret.inc file that is included in this code. And since the file path that leads to the includes directory appears to be a relative one, we can assume that we are able to access it from this website. So from the address bar, we add includes/secret.inc to the end. As we can see, there is PHP code in this file, and the secret variable is defined with this value here. So we can highlight that value, then copy it with Ctrl+C, then go back up to the address bar and go back to the Natas 6 landing page. Then paste the value into the input secret field and click Submit. The password for Natas 7 is revealed, so we copy the value and add it to our Natas password text file. That's the end of Natas Level 6. Before starting Natas 7, let's go over a couple of concepts that will help in completing the challenge. URL parameters are variables attached to the end of URLs. They can be identified by the question mark directly after the web page or directory name, followed by the parameter key name, then the equals sign, then the value. If there are multiple parameters included in the same URL, then they are separated by the ampersand symbol. There are a few different reasons why web pages use URL parameters. The most common one is for search queries. However, another common and potentially dangerous use of URL parameters is to instruct the web server on which web page to display. The use of URL parameters which reference other files on the web server could potentially be exploited in an attack called local file inclusion. Local file inclusion is a web app vulnerability where arbitrary local web server files can be accessed through a web interface. LFI vulnerabilities can lead to sensitive data exposure and can also be used as the first step in a chain of exploits. The inclusion of file names in URL parameters is a typical method through which a potential LFI vulnerability is identified. We log into the Natas 7 webpage in the usual manner, and we see here that there are two links. If we click on the About link, we see that the address bar at the top of the browser now includes URL parameters, which appear to include the file referencing the page we're looking at. We can confirm this by clicking on the Home link. We can surmise that web page files are passed through URL parameters and returned to us through the web browser. This is an indication that a local file inclusion vulnerability may be present on this web app. One way to test a web app for LFI vulnerability is to try and access a common file on the underlying web server that is not normally accessible by the web app. In the address bar, we can substitute the name of the page with the following string: a series of ... slashes, followed by /etc/password. Note that the spelling of password is non-standard. But why this particular string? From the Natas game instructions, we know that the Natas CTF web server is running either Unix or Linux as its operating system. In Linux, ... in a file path indicates going up one level in the file system. And doing this several times allows us to go up to the top level of the file system. Next, we supply the name of the common Unix/Linux directory, etc., which contains system configuration files. Then another slash, and the name of the file we want to access, which is the password file. This file doesn't contain passwords, but it does contain a list of all of the web server's user accounts. But why do we have to go up to the top of the file system with the ... slashes? That's because web apps are designed to only have access to a limited number of files and directories, which are usually located several layers down in the web server's file system. So we use the ... slashes to navigate to the top of the file system, then supply the file path for the file we want to access. And from the output, it looks like this app is vulnerable to local file inclusion. But how does this help us get the password for Natas Level 8? If we recall the Natas CTF game instructions, they tell us where the password files are. This detail was included for those levels of Natas that allow us to interact with the file system of the web server, like this level. So to access the password for Natas 8, we can keep the beginning of the LFI string the same. But instead of accessing the etc password file, we access the etc Natas webpass Natas 8 file. We've successfully accessed the Natas Level 8 password file. So we copy the password and paste it into our Natas password text file. That's the end of Natas Level 7. We'll log into the Natas 8 webpage in the usual manner. On the landing page, we see that this level is similar to one we did earlier, with a secret input and a source code file available to us. In the source code, we see that there is PHP code here for us to analyze. We see that the encode secret function is applied to the input that we supply. And if that output matches the encoded secret variable that is defined above, then the password for Natas 9 is printed out. We should note that our input should not be the value of the encoded secret itself, but rather a value that will equal the encoded secret after it's been run through the encode secret function seen here. So to solve this level, we need to understand how this PHP function works. A key concept to understanding the function is knowing how nested operations work. Nested operations involve passing the output of an operation to another operation. In this PHP code, the operation on the innermost layer of parentheses is the first operation. Then the result of that operation is passed to the next operation, which is one layer of parentheses outwards, and so on, until we escape all of the parentheses where the last operation is executed. So in this function, the secret, our input, is encoded into base 64 encoding. Then the resulting string is reversed, that is, printed out backwards. Then that string is converted from binary data into hexadecimal numbers. We can confirm that the last step converts the data into hexadecimal numbers because the encoded secret variable appears to be a hexadecimal number. So we can reverse engineer the original value of the encoded secret variable by performing the reverse operations of the encode secret function in the reverse order. Since the binary to hexadecimal conversion occurs last, we perform the reverse of that operation first, which is a hexadecimal number to binary data conversion. Then we perform the reverse string reverse operation, which is the same operation. And finally, we convert the reverse string from base 64 encoding back into its original encoding using a base 64 decode operation. Since this code is written in PHP, we'll use PHP to reverse engineer it. In another web browser tab, we navigate to the onlinephp.io website. This site lets us see the output of PHP code without the hassle of installing PHP on our computer. Going back to the Natas 8 source code, we copy the code snippet, then paste it into the online PHP window. First, let's change the name of the encode secret variable to secret so it fits the function's arguments. Then we change the name of the function from encode secret to decode secret. We will delete the portion of the code from lines 9 to 15 because they're not required right now. At the end of the code snippet, we'll use the echo command to output the results of the function to the console. Note, all lines of code in PHP must be terminated with a semicolon. We know that the first step we want to do is convert the secret from hexadecimal numbers to binary data, so we use the hex to bin function as our first operation. The string reverse operation will remain the same, and the last operation will be decoding from base 64 format into the original format, which in PHP is the base 64 decode operation. Click on the Execute Code button below the window, and the decoded secret appears in the console window below. We copy that string, go back to the Natas 8 landing page, and paste that string into the input secret field then click Submit. We now have the Natas 9 password, which we copy, then paste it into our Natas password text file. This is the end of Natas 8. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. Before moving on to Natas 9, let's learn about a new web app vulnerability that we'll use to solve the Natas 9 challenge. Operating system command injection is a web app vulnerability where arbitrary OS commands can be performed on the web browser through a web interface. OS command injection is a serious vulnerability and can often lead to complete compromise of the web server. And if so, the web server can be used as a foothold to attack other machines on the network. We log into the Natas 9 webpage in the usual manner. And on the landing page, we see that there is some sort of search function here. Since there's a View Source Code link, we should click on that and take a look. There's more PHP code here. But one important thing to note is that the PHP pass-through function is used. And the pass-through function is used to instruct the web server to execute commands through its operating system. If this kind of function is not coded in a secure way, it can leave the app vulnerable to OS command injection. The actual OS command being passed through doesn't matter if there is no filter being applied to the input. We go back to the Natas 9 landing page and use the following string to retrieve the password for Natas level 10. cat /etc/ Natas webpass /Natas 10 number symbol. Let's break down what this Linux command does. The semicolon at the start of the command is a terminator, so whatever other command the pass-through PHP function was going to run is interrupted. The command we run is called cat, which is the typical command used to read files in Linux. Next is the file path leading to the Natas 10 password file. And finally, the number symbol comments out whatever else the pass-through PHP function was going to run. When we click the search button on the web page, we receive the password for Natas 10. So we copy the password and paste it into our Natas password text file. That's the end of Natas 9. We log into the Natas 10 webpage in the usual manner. On the landing page, we see a message indicating that certain characters are being filtered by the web app. If we click on the View Source Code link, we can see that the PHP function is very similar to the one used in the previous level, except that if the user input includes any of these special characters, an error message will be displayed. That means we can't use the same command we used in the previous level to gain access to the password, since that command required us to use the semicolon as a component of it. We'll need to look at the command the web app is running via the pass-through PHP function. The Linux command is grep, which searches through specified files for text strings and returns instances of those strings if found within those files. The -i portion of the grep command indicates that it will not differentiate between uppercase and lowercase letters in its output. This all being said, this means that we can use the grep command for its intended purpose as a means to read the Natas 11 password file. We go back to the Natas 10 landing page, where we supply the search field with the following string: a/etc/Natas webpass /Natas 11 #. Once again, we use the hash symbol to comment out the rest of the Linux command, since that symbol is not filtered. So this command will use grep to read the contents of the Natas 11 password file if the contents of the file contain the letter A. The current password contains the letter A, so we're able to read it. If we didn't receive the password on the first try, we could have repeated the process with the letter B, then the letter C, and so on. Having received the Natas 11 password, we can copy the password, then paste it into our Natas password text file. That's the end of Natas Level 10. Let's review the web exploitation concepts we learned in this workshop. Source code analysis is the process of analyzing the code of a piece of software with the goal of deeper understanding regarding its function. It is a common technique used in software security testing, but it requires the software's source code be readily available. URL parameters are variables attached to the end of URLs. They are often used to send search queries to web servers, but they can be used to retrieve other data as well. Local file inclusion is a web app vulnerability where arbitrary local web server files can be accessed through a web interface. LFI vulnerabilities are typically identified when file names appear in URL parameters when accessing web pages. Operating system command injection is a web app vulnerability where arbitrary OS commands can be performed on the web server through a web interface. OS command injection can often lead to complete compromise of the web server, and if so, the server can be used as a foothold to attack other machines on the network. In the next HackerFrogs AfterSchool web exploitation workshop, we'll learn about the SQL database language which most web apps use for user account credentials. Looking for more study material on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs!